Hello and welcome to Ganesh's YouTube channel. So today we are going to discuss about maxima and minima with respect to partial differentiation. So whenever you're given with a question that you need to find out extreme values that for which you can have maximum or minimum value of that particular function, then you need to find out maxima and minima with respect to partial differentiation. There are some sequential steps for that, and I'm telling you how you can elaborate it. Let's begin with an example, okay? So here you are given with a function in terms of x and y, and you have to find out the extreme values, okay? So what you need to do, this is fxy. First of all, your step 1 is differentiate your function with respect, partially with respect to variables, okay? So with respect to x, with respect to y, this is 4x cube minus 4x plus 4y, right? Rest all are constant because you are partially differentiating it with respect to x, that's correct. Similarly, when you find out partial differentiation with respect to y, you'll see that this is 4y cube, this is 4x and minus 4y, correct? Now, you have to put these values as 0. So, your next step is finding out the value of x and y by putting your partial differentiations as 0. Okay. So, this is your step number 2. Let's begin. So, if you put it as 0, you can take 4 common. So, what is left? X cube minus x plus y. And for this, y cube plus x minus y, right? If you try to solve this, you can simply add so that these two will be cancelled. What is left? X cube plus y cube. You know the formula of a cube plus b cube? What is it? A plus b, a square plus b square minus ab, right? If you put this as 0, so your x will be minus y. Now put this x is equals to minus y into any of these equations. So I'm putting into first. So minus y cube minus y plus y equals 0. So you can see y cube plus 2y 0 minus y cube plus 2y 0. So y cube will be minus 2y. Y cube will be 2y, right? Or you can do it like this and take y common. So y square minus 2 equals 0. So here you've got 3 values of y. Y equals 0 and y plus root 2 and minus root 2, right? Now these are your values for y. So if you put here y as 0, you'll get x as 0, y as root 2, then minus root 2, and y is minus root 2, then x is root 2, right? So this was your second bit. You have got your 3 values for x and y, 0, 0, root 2 minus root 2, and minus root 2 plus root 2, right? Now, your third step is to find out r, s and t. I'm telling you what are they. I know you might be thinking of what are r, s, t. So here we go. In order to find out 3 other functions or variables, r, s, t, what you need to do, your r will be double differentiation of function with respect to x, your t will be double differentiation of function with respect to y, and your s will be take any of these function and partially differentiate it with respect to another variable. So if it is with respect to x, then differentiate it with respect to y, and if it is with respect to y, then differentiate it with respect to x. So what you can write it like? You can write it like, correct? Now find out the value. So if you again differentiate it with respect to x, what will you get? 12. Let me write it down. you will get 12x square minus 4, right? If you differentiate it with respect to x, you will get 4. And if you will find out double differentiation of f with respect to y, you will get 12y square minus 4. Correct? Now, this was your third step. What you need to do, try to find out RST for these coordinates. So, at 0, 0, your R will be minus 4, S is 4 because there is no variable to put down the values, and T is again minus 4 because you are putting X and Y 0. Then if you are putting root 2 minus root 2, your R, root 2 square is 2, 12 times 2 is 24, 24 minus 4, 20. S is still same, 12 minus root 2 square will also be root 2. So 12 times 2 is 24 minus 4, 20, right? Similarly, if you find out with minus root 2 and root 2, again that will be same because it is square and minus sign doesn't matter. So 24, 20. Once you will find out your RST, what you need to do, your step number 4 is find out RT minus S square. Okay, as we did in double differentiation, we put double differentiation, we find the value of double differentiation and check it out whether it is greater than 0 or less than 0 or equals to 0. Similarly, what you need to find out here is RT minus S square. So check it out whether it is greater than 0, equals to 0 or less than 0 with respect to R. So let us find out. For this, your RT minus S square for 0, 0, R is minus 4, T is minus 4, minus S square is 4 square. So 4 times 4 is 16, minus 16 is 0. Whenever you will get RT minus S square is equals to 0, then there is a possibility, there are 3 cases. Let me write it down here. So, if RT minus S square is greater than 0 and if RT minus S square equals 0, there are 3 possibilities, okay. If it is greater than 0, then there are 2 cases, whether R is greater than 0 or R is less than 0. If R is greater than 0, as in these cases, then it is minima. If R is less than 0, firstly find out whether this is greater than 0 or not. If R is less than 0, then it is maxima. Okay. And if RT minus S square is 0, then that is a saddle point. And we cannot find out minima or maxima. Okay. Now, you can see your RT minus S square is 0, so this is saddle point. For this, you can find out your RT minus S square, 20 into T is also 20, minus S square, which is 4 square. So 400 minus 16, which is 384, right? 10 minus 6, 4, 9 minus 1, 8, yes, 384, which is greater than 0. So these 2 conditions are similar, same. So these are satisfied. Now check it out whether R is greater than or less than 0. So R is greater than 0. So this is the condition. So it is minima at R is equals to 20. Okay. So these are your value for X and Y or this, right? So your minimum value of function will be, in this function, put X as root 2 and Y is minus root 2 and find out the values of F for this point as well as this point, because these two are showing minima. Because for these 2 points, your RT minus S square is greater than 0 and your R is greater than 0. Because these 2 conditions are satisfied, that's why it is a minima. And to find out where it is, means which point is the minimum point, so you have to check out these 2 coordinates with which you went along. So these 2 coordinates, put them into the main function and find out the values. Those will be your minimum value points. So let me do it once. So x raised to power 4, I'm doing it for this. Let me grab this again. So x raised to power 4, I'm putting x as root 2, y as minus root 2. So root 2 raised to power 4. So root 2, root 2, root 2, root 2. What it would be? 2 and 2, 4. Plus, similarly it would be 4 minus 2 x square. 2 times 2 is 4 plus 4 xy minus 2 minus 2 y square is 2. So 4 is cancelled with 4 minus 8 minus 4. So what is left? Minus 8. This is your minimum value. Okay. I hope you understand this topic. This is something which is easier if you follow the sequential steps. Firstly, find out partial differentiation with respect to x and y. I'm just recapitulating. And thereafter, what you need to do? Put them as 0. Find out the values, coordinates for x and y. Thereafter, find out RT minus S square. If it is greater than 0, then there are 2 conditions. Whether R is greater than 0 or less than 0. If R is greater than 0, then that would be your minima. And if it is less than 0, then it would be maxima. And then find out the values, minimum value and maximum value by putting those coordinates back into the function. This is how you can solve your maxima and minimum problem. If you feel any query regarding it, you can comment in the comment box. And if you like this video, don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye-bye.